Everybody. In this video, we're going to discuss how to solve dynamics problems. So it all starts with what's known as a free body diagram. So let me set up an example. Let's say there's a pulley here, and then you hang a weight on this side, and then another weight on this side connected by a string. So there's a string going over this pulley. Then you put a mass on this side and a mass on this side. So let's say this is 2 kilograms and this is 2 kilograms. And you hold each one with your hands and then you let go. Nothing happens, right? But what if maybe this one is more? Like this is 5 kilograms, right? Then you hold one in each hand, let them go. What's going to happen? Like this is going to go up, this is going to go down, right? And the pulley is going to rotate like this. So let's say you want to solve for the acceleration of the blocks. How do you do that? So it starts with free body diagram. So you take this block and you draw it free of its surroundings. So it's just, this is the free body diagram for block 1. Free of its surroundings. And you draw all the forces acting on the block as vectors. So, okay, you're like, all right, there's this string over here. So there's some tension. I'll just call it T for tension. And then the block itself has weight. So it has weight. Weight of block 1, which is just mg, right? So that's it. That's the free body diagram. How about the other block? Okay, so I'll draw the block free of its surroundings. So just like that. And then all the forces acting on it. There's this string over here. So there's some tension. The block itself has weight. The weight of block 2, which is mg. So there we go. We got the free body diagrams. Now that you have the free body diagrams drawn, step 2, pick coordinates. So it's up to you. Like you can pick coordinates however you want. You could go like this and like this. But just note that what's really going to happen is this block is going to go down in the negative y direction, right? This block is going to go up in the positive y direction. So then the acceleration of block 1, ay, is going to be positive for block 1, and the acceleration in the y direction for block 2 is going to be negative. So ay for block 1, ay for block 2 are like opposite of each other. I personally would rather not deal with that. So my personal preference is, since I know block 1's going to go up, I'll draw it like it's moving in the positive direction. I know block 2 is going to go down, so I'm going to draw y this way. So they're both moving in the positive y direction. That's my own personal preference. You can draw your coordinates however you want, because everyone has that freedom, right? For example, you could say, no, I want to make this x, right? So block 1 is moving in the positive y, block 2 is moving in the positive x. That's totally fine as well. There's no wrong choice for coordinates. So this is just personal preference. Okay, so that's step 2. Step 3, let's write out Newton's second law. Newton's second law is the one that looks like this. But let's decompose it into components. So instead of Newton's second law being this vector equation, we'll split it into just the x component, just the y component. So you add up all the forces in the x direction, and it's going to be equal mass times only the x component of the acceleration. Similarly in y, you add up all the forces in the y direction, right? So that's the y component of this, equals mass times only the y component of this. Right? So we decomposed this vector equation. So let's try that. So for block 1, let me move this. So for block 1, sum all the forces in the x direction. There are none, so that was easy. Okay, sum all the forces in the y direction. So this way is y. So that means t is positive. Positive t. Since this way is y, this is negative. So that's negative m1 g equals mass of block 1 times acceleration, but only the y component. I didn't write here. This is mass times acceleration, only the x component. Okay, so now let's try this for block 2. So in the x direction, nothing's happening. There should be mass 1. In the y direction, so I picked y this way. So that means this is positive and this is negative. Mass 2 times acceleration. Okay, so let's say we know the masses of, right, like 2 kilograms, 5 kilograms. So we know M1 and M2. What is unknown? So now step 4 turns into a math problem. Right? What is unknown? So we don't know this, a y. Oh, there should be a y over here, right? Okay, so we have two this is just 0, right? So let's just say we have these two equations and 2 unknowns. So you know how to solve 2 equations for 2 unknowns, right? Just, let's say, solve this for t, and then substitute that there. So minus t and then simplify, right? So there's ay over here, ay over here. So I'll move this on that side. And I'll move, okay, so that's minus, so it becomes plus. And then this minus factors in here, so I didn't write, this should be a minus. Okay, and then let's simplify a little bit. And here we go. So there's the acceleration of the block. They both have the same magnitude. The direction is, right, this one's going in this direction, block 2 is going in this direction. Okay, so just remember the steps. That's what's important, right? The steps. So step 1, draw the free body diagram. Step 2, pick coordinates. And do it in this order, right? Don't decide on your coordinates and then draw the picture. You should draw the free body diagram first, then you pick your coordinates. Then you write Newton's second law. but decomposed into the coordinates that you picked here. And then last step, you solve whatever math, right? Solve math. Okay, so let's do a bunch of examples after this. So I'll see you in the next video.